Welcome to EDU World Space.
All right, so we are analyzing an anemometer, and we want to get the angular momentum if given a certain speed. So let's get down the givens, and then we can discuss how to do the problem. So each has a mass of 100. Each of these little cups has a mass of 124 grams, so 0.124 kilograms. And then I'll just put a note times 4. Are they all at the same radius? Yes, they are. And speaking of that, they are, they're mounted on rods. Okay, great. So then that's R of the rod is 0.326. Meters, and the mass of the rod is 0.0757. Kilograms. 1, 2, 3, yeah. And then let's call these the mass of the cup. So MC. Now, let's see. We want the angular momentum if it's spinning at 12.4 revs per second. Don't forget, we got to convert this into radians per second if we want to call it an omega without confusing ourselves. So there's 2 pi radians per rev. So we can just make the units of this now radians per second. Let's make this a nice long equation. That's how we meant it to look. Okay, excellent. And so now our goal is to get L. So basically we want to get, L is I omega. So we want to get I of the system. One thing about I is nice is you can just add you can like take the moment of inertia of each thing in your system and just add them up. So we have, let's just draw this out. Let's just draw one of them. So here's our rod, here's the cup, and these we can take as point masses. So those have a moment of inertia of mr squared. So that's mc plus r squared. And then these are rods. So we just need the moment of inertia of a rod. I think it's 1/3 ml squared, but I'm just going to look it up. So yeah, it's 1/3 ml squared. Why did I doubt myself? So, and then the length of the rod is r. So 1/3 m rod r squared, and then times omega. So that's it. And then, oh yeah, we need to multiply this whole thing by 4 because there's 4 of these cup rod systems having angular momentum. So now I'm going to pull up a calculator and plug everything in. So we're going to do 4 times 12.4 times 2 pi times the mass of cup is 0.124 times 0.326 squared plus 1/3 times mass of rod 0.0757. Is that what it was? 757. I'm going to double check these numbers all at the end. Times again r squared 0.326 squared. And you know what? I think that's it. So I got 4.94 joule seconds, and that's not the answer that somebody else who did this problem got. So I will double check everything. So 124 grams. So, and then 12.4. Oh, that's confusing. Okay. So 4 times the omega, 12.4 omega, yes, times the quantity, 0.124, 0.326 squared plus 1/3, 75.7, 1, 2, 3, times 0.326 squared again. Yeah, I stand by my answer, so whatever. So I say it's 4.94 joule seconds. This other answer, it looks like it's almost like a fourth of this. No, not quite. I was like, maybe they forgot to multiply by 4, but I don't really know. But this is the answer that I got.